In a few of my recent videos I mentioned having a slight problem with the lathe at the moment, which is a slow startup problem. Hopefully I can demonstrate here. Right, that should be running at 800 RPM and obviously it isn't even vaguely close. And then just sits there and chugs along at that unless I give it a boost. So, most likely problem, the reason for this problem is the fact that the capacitor that generates the false two-phase to get the motor spinning, the second phase, it's only a one-phase motor but it creates a second one by using a capacitor, has failed. They are apparently notorious for doing this, so I've spun the head round and I'm going to try and change out the capacitor and see if we can improve the situation. Obviously when you're dealing with lathes and doing your electrical work or changing belts, the most important thing to do is unplug it. So there we are, all safe and sound. Now the capacitor is an electrical storage device, so it's potentially going to have power in it when I take it out, so it means it needs to be handled carefully and preferably discharged. Lots of ways of discharging it, using a load like a light bulb, or in my case I'm going to use a voltmeter or an amp meter, just to put a high load across it and drain it down. And be careful how I handle the leads up until then, and obviously don't want to get a shock. And then we'll try fitting the new capacitor, which I've got here. There we go. Matches the one that's in there, 10 microfarad at 470 volts. All the information on the side there. So we're going to try changing that out and see if that improves the situation. So stick with me. So the first thing I need to do is get access to the capacitor. Now be a bit careful with the screws at this point, because the last time I did this I locked one straight down inside the fan cover, which was a bit of a pain. I'll take the fan cover off to get it back. So okay, and that's where the capacitor sits. Right, while I've got a chance I'm just going to give that a quick vacuum up and then we'll come back to discharging the capacitor. So there we are, a bit cleaned up, and you can see a good shot of the old capacitor and its specs, and the new one matches. So what I've got to do now is put a discharge across these two leads, ensure this is actually flat before I cut it away, and then I want to re-crimp, which is all it is. It's just crimped onto these two red wires coming out of the motor. So I've just got to re-crimp the new one across there, and then we can see if we made an improvement. Okay, so firstly let's start off and get it discharged. Okay, so I've got the meter set to milliamps, the lead plugged into the right one, and I'm just going to see if there's any current present. I've got nothing there. Let's just take it over to the milliamp range on the plug-in and just see if I've got anything reading there now at all. No, I'm getting nothing. I suspect this capacitor has somewhat had it. Okay, so having established that I'm pretty sure there's no power in this, I'm still going to disconnect it fairly carefully, just cut it away this side of the crimps. I'm going to put some new crimps on, but I'm going to cut it one leg at a time using insulated cutters. I'll just cut the old one out. Right, that's just going to be sensibly disposed of now. I doubt there's any useful value to it, so I will get rid of that. And now we need to install the new one. So I need some electrical crimps. I'm going to trim these ends down and I can reinstall it. Just on the notion that it is nice to share when you discover something good. These are made by CK, they're wire strippers. I also have the crimps built into it so you can use them as a crimping tool as well. I've used them for a bit now and they are absolutely superb. You don't need to make any adjustments. The blade mechanism just clamps and strips the wire for you of any diameter. So that'll do mains sheathing cleanly, and then actually do the trim the cables itself down to some very fine stuff. No need for any adjustment. I think they're brilliant and I'll be using them here. So straighten the wires up a bit and then just trim a suitable length to go into the crimps. Right, so these are the crimps I'm using, and I'm just going to crimp one end onto each of these. Like so. Okay, make sure they're nice and mechanically firm. And then, I've got a lot of lead here, I'm going to trim down the capacitor leads. Leads aren't colour coded because this, I believe, is not polarity sensitive. And we'll just trim off those two and put them into the other end of the crimps. In fact, they look, I'm going to just shorten those two leads a bit because there's a little bit of wire still exposed, which there doesn't need to be. And then just use the crimpers to crimp this end. Crimp in the middle as well. Give it a bit of a tug just to make sure it really has gripped the cable, which they seem to do rather neatly. And again, just a couple of light crimps to make sure it's done the job. Right, so before I put the cover back on, it's the moment of truth. So that's the power replugged. Let's see what happens. And there you go. Lovely, so straight up to speed immediately, no lag. That seems to have fixed it. So there you go. If your lathe is behaving like that and you're just not getting it to start properly, chances are, if it's not your belt slipping, which you probably will hear, your capacitor's probably failed, and these Chinese lathes apparently do use slightly cheap capacitors which are prone to failing. So I'm just going to now reassemble, put the case back over that, get it all secure, and I can get back to turning. See you in the next video.